Amazing. Okay, so like Charm said, solving linear systems by graphing. We have two linear equations here. What we're going to do is we're going to graph the two of them, and to solve a linear system is to find the point of intersection between the two lines. Now, this first linear equation we have is already in our y-intercept form, so we'll call this our number 1. Okay? If I were to graph this, where would I start? -3. What is -3? That's right. That's the y-intercept. Okay. So we go down to -3. Do it in green here. And then from -3, where do we go? In order to draw a line, I need at least 2 points. So what would I do from there? Use the rise or the run, which is the slope. This is our m, right? It's already in that form. It should be an m. So this 1/2 m is our rise or our run. So we rise +1, and we go horizontally +2 from that spot. And we just repeat that pattern. I guess we'll do it in green. So I would go up 1 over 1, 2. Up 1 over 1, 2. So the larger ones are the dots here. Up 1 over 1, 2. Okay, what if I wanted to go the other way? What would I do? Down 1 and to the left 2. Right? I would do negative and negative. And the reason that works is what's a negative divided by a negative? Still get a positive, right? So we go down 1 over 2. So we could just extend this line. Okay, I'll put this line in green. So if we were to extend this line, it should go from about here, about like that. Let's go down this way. Okay, so here's our line. There's our first equation. We'll call that line number 1. Now, line number 2, I guess we'll do it in red, is here. Can I graph line number 2 by just looking at this? No, why not? What form am I not in? Yeah, I'm not in my slope y-intercept. How do I turn it into slope y-intercept? What do we got to isolate? Y. We have to isolate y, just like we did above here. So I'm going to retake this equation, or rewrite it down here. X plus y is equal to -6. Okay. Okay, so in order to isolate y, we have to move x to the other side of the equation. When we do that, we'll end up with y is equal to -6 minus x. Now, this is not what we're used to seeing. We're used to seeing our coefficient and our x as the first term, and then our constant as the second term. So I can rearrange this. If I were to move the 6 behind the x and the x in front, what would this read? That's right, y equals -x minus 6. It's the exact same thing as above. And if you're able to look above and figure out the slope of y-intercept, you don't have to take that extra step. But we do that so it helps us recognize what is our y-intercept here. That's right, -6. So we go down to -6 on the y-axis, and we draw our point. From there, what do? What is the slope? Is it just +1? It's actually a negative. So it's -1. And how do I make that a fraction for the rise over a run? I just put it over 1. So my rise is to go down 1, and my run is to go in a positive direction 1. So we go down 1 over 1. Down 1 over 1. Down 1 over 1. The opposite of that, I'm going to say or, I go up 1 to the left 1. So up 1 to the left 1. It's still negative. Up 1 to the left, up 1 to the left. And already we'll notice that these two lines are going to intersect each other. In other words, they cross. And at what point do these cross at? -2 and -4. So this is the coordinate where the two lines intersect each other. Okay? Now, to make sure this is true, we need to plug this into the other equations. Now we can look at this, and this will just be a check. From here, this could be our answer. Our answer, or the solution to this, is -2 and -4. Okay? To make sure this is true, we can plug this into both of the equations. Okay? And what we just got to make sure is that the left side equals the right side. So, I'm going to take both of the equations from above. I'm going to rewrite them down here. Okay? And I'm going to split this in half. We're going to do it at the same time. The first equation read y was equal to 1/2 x negative 3. And the other equation, we'll even take the original equation, was x plus y equals negative 6. Okay. Okay, we're going to take this coordinate. This is the x and this is the y. This is our way to check. We've already found it, but we're going to plug these values in for the x and y in both equations and make sure that the left side equals the right side. So, for our y, we'll replace it with negative 4 is equal to 1/2. And what was our x value? Okay, so 1/2 times negative 2, and then minus 3. We're going to see if, when we equate all this, it equals negative 4. So what is 1/2 times negative 2? Negative 2 over 2, which is? What is negative 2 divided by 2? Anyone know? Yeah, negative 1. Okay, so this is negative 1 minus 3 is equal to negative 4. What is negative 1 minus 3? Negative 4. So, does the left side equal the right side? Yes, that checks out. In other words, that point exists on that line. Okay? We just have to make sure that point exists on the other line we had also. So remember, our x value was negative 2, so we'll replace x with negative 2. And our y value was negative 4, so we'll replace our y with negative 4. And we'll test to see if this works. Negative 2 plus negative 4 equals negative 6. Now remember, if I have a positive and a negative beside each other, how can I simplify that? Right, we just make it a negative. Equals negative 6. Okay. And what is negative 2 minus 4? Negative 6. Does the left side equal the right side? So that point exists on that line. So we know this is truly the point of intersection. We've gone about checking. Okay?